We have done the regression analysis of the dexterity and productivity. We have got the hypothesis of the beta naught and beta 1 tested. We also tested the hypothesis of R square as well, the overall reliability of the model. Let us do the hypothesis test for rho equals to 0, that is the correlation being 0 or not. So for that we need to compute the test statistic. So test statistic T will be given by, let me record the value of n and n minus 2 first. N is here, R is here, yeah, that's what we need. So n is 5 and R is given by this formula, or we can just use the Corel formula to get it. Comma here. So we got the n and R, so let's compute T. T will be equal to R multiplied by square root of n minus 2. So n minus 2 divided by 1 minus R square, 1 minus R square. So this is our value of T. So what is the area in the tail for the T value of 5.54? So here we will determine the P value is equal to T dot inverse, and it's a two-tail test. So we need to calculate the distribution. So that will give us the so the x is this and degrees of freedom is n minus 2, and we find this to be 0.01. So we see that the R square, the correlation R is significant at 5% confidence level. We can also see it visually as well. When we take these dexterity and productivity, we can go ahead and insert a scatter plot, and we see the productivity. I can move it to a new sheet, scatter, and I can change the axis, make the minimum to be 10, and change this axis also, the minimum is 50. So here are our 5 points. Let's fit a trend line on top of it, which will be our linear regression. Okay, let me close this. Right click at trend line, display the equation and R square. In fact, these are the values that we have derived using our analysis as well, and we see that there seems to be very strong correlation here. We can also calculate the estimated value of y hat of productivity using our derived coefficients. So is equal to beta naught plus beta 1. Okay, I need to ensure the referential integrity, plus beta 1 multiplied by x. So this gives us the y hat, and we can get all the y hats, and then we can also compute the residual epsilon, right, which is your y minus y hat. the expected value of this, we expect it to be 0. So let's look at the sum divided by n. This is a very minuscule value. I can convert it into numbers. So it's only a rounding of error, otherwise it's 0. Divided by 5 will be 0. So we have derived all values. We have tested for all the hypotheses except for the beta naught being insignificant. Rest of the model is significant.